will be looking at the time, and at the same time, I want to cover a few lecture slides. So once I'm done, I'll start the video. Okay? Right? So we are learning data science, right? And yeah, are we collecting data as well while doing data science? Are we collecting data? Are we the part of the data that is being collected? Yes, data is being collected, right? Now, it may not relate with data science, but let's try to understand, okay? As a data scientist, what kind of data do we need? If we are given the chance to collect data, if we are given the chance to collect the data, then data should be I can ask these crazy questions in your quiz, right? So the message is, when we are collecting data, when I am collecting data about your attendance, there is a purpose for that data, right? If a student has signed, then that means the student attended 5 minutes, 10 minutes, 30 minutes, or the whole lecture. It should be the whole lecture, right? The message is, if you are signing on the sign-up sheet, then for me, that means the student is attending the whole lecture. So please don't, try to outsmart me. I've noticed a few things, right? Maybe in a couple of lectures, students have this pattern. You're smart enough, you can see my pattern, right? Like maybe I'm giving you the attendance sheet in the beginning, you will sign, and then 15-20 minutes. That data is not a correct data. When you're signing the sign-up sheet, please stay in the lecture, okay? Just thought that maybe we should discuss about it. When we are the part of the data, right, that the data should be authentic. There are some possibilities, right? And I believe that this has happened. Maybe student is absent, but still the signature is there. You know what is happening, right? So thought, okay, since our data is being collected, which will help you know extra credit, make sure that the data is authentic. Okay. Now back to what we were discussing. A very interesting definition. Any question about what I discussed the last couple of minutes? Okay. I am collecting data. You are helping me in the data collection whenever I'm passing on the sign-up sheet. When you are present, you are signing. When you are signing, then it is understood that you will be staying for the whole lecture, unless you have any emergency. That's all right. Okay. Back to the definition, and I shared the practice test also, right? And in the practice test, there is one question from question number 6, which we did not discuss yet. So you can ignore question number 6. That's based on the next topic that we'll be discussing after this one. Question number 6 you can ignore. Now, I do remember that in the practice test, there is a question. We'll go over that, right? The question is about, does anyone remember, related with what we have here? You don't have to, provide me the exact question. Vaguely, if you remember, what was it? Sorry? What is machine learning and how is that different from conventional programming? This is an open-ended kind of a question. So if I'm asking that kind of a question, feel free. Make sure that you are conveying the main idea behind that. So the reason I thought, okay, fine. If you know this definition, great, right? I found this the perfect definition of machine learning. Otherwise, you can define machine learning in your own word. Make sure that it is conveying the idea. We will discuss about that. Right? I have the solution of the practice that I've given, which I'll be going over towards the end, and I will also share that with you. I will post that on the Brightspace. Good. So One more time, let's go over this thing and then I'll take you to the next slide, which is again very interesting. So machine learning. In machine learning, we'll have a program which we'll say is, okay, let me read it without changing anything in this definition. A computer program is set to learn from experience T with respect to some task T and the performance measure P if its performance at the task T as measured by P improves with experience E, and yeah, this is by Talmadge. When I'm asking you the definition of machine learning, it should not be exactly the same way. You can have your own definition. Make sure that there is the key idea that it is a program that is learning from the data. Okay? In conventional program that we will be writing, I'll share that answer, right? The perfect kind of answer. In conventional program that you write, we don't usually learn from data. We know the conditions well in advance, right? Like an example, probably I gave that thing to you, right? Fine. The grades of the student is provided to you, right? The data is pretty big. You have about 1 GB of students' grades data, numerical grade, okay? And now we need to assign the letter grades to the student, and the rule is given to you, right? Like, okay, if the student got 95 or higher, it's an A, right? So when the rule is given to you, you don't need to learn anything, right? If else, or switch statement, whatever. If an else, you can write it, then you're done. Anyway, this is an interesting slide on machine learning itself, where we are trying to explore different things that a machine learning algorithm can do or a model can do. So let me read that and then we'll have some discussion. We have seen an example. This is machine learning, sorry, not machine learning from, sorry, it's not even learning from. It's Python for Data Science Part 2, if I could correctly remember the lecture slide topic. Python for Data Science Part 2. And yeah, what did we do in the initial slides? We got some data, right? And it was about planet motions, if I correctly remember. We applied log transform, tried to fit a line, and in the process we learned about linear regression, simple linear regression. That's what we have learned. But machine learning has a lot of other models as well. So what we have here, now instead of restricting ourselves to linear boundaries, well, we did not do any boundary kind of a thing. I should say line fitting or linear regression. Okay. So let me read it first and then I'll tell you why did I write linear regression, but let's read it. Instead of restricting ourselves to linear boundaries, we generalize to more complex functions and different type of target variables. So actually I'm not happy with the boundaries term over here, right? Because boundary is something that should come when we discuss about classification. So here, what I would like to say is, instead of restricting ourselves to only the case where we are trying to fit a line to the data, we can think beyond that. Beyond that means, well, our data that we have could be explained by some polynomial function, by exponential function, right? So here we are extending our definition of machine learning, what we saw doing that exercise and what we can do, right? So, but if you want, we can keep it as it is, instead of restricting ourselves to linear regression or linear boundaries. We can generalize to more complex functions, and we can also have different kinds of target variables. So here, guys, there are a few things we need to understand. This is not the part of your quiz syllabus, but anyway, it will be important for the next test, which will be your midterm. So let me read these things first, and then I'll have some discussion over here. So when we are saying we can go to more complex functions, then more complex functions means the polynomial function, non-linear function, and discrete target variable. Good. we will discuss those things, right? But before that, let me ask you this question: what is a target variable? Where's the honest answer? Did we discuss about? Yeah.
Like the variable that has something to do with the pattern of the information. Because some variables are not related to the information.
When you are in doubt, use an example.
Like,
Okay?
say in the Titanic example, the room number or
The room number.
are not related to survival, but the number of family members or gender or social economic class.
Interesting.
These variables are target variables.
What is target variable here?
Like the variables that are relevant to the survival rate, like predictions or trends or patterns.
Interesting, right? Yes. Survival is? Who will determine what is the target variable? You have the correct answer, right? But I want to have a slightly more general. I'll give you, yeah, that's correct. Yeah, let's discuss if we can have more example. That's a better answer, right? Good. You know, your answer is related with what he started, right? So I'll say you both as a team get 100% because he started the discussion. Titanic data. Okay? So for Titanic data, seems to be the case that we want to predict whether the individual survived or not. Good? Right? So here, it is kind of known that we want to predict survival. So survival is the target that we want to predict. Okay? And the remaining variables that we have in the data, they are independent variables, you can call it, right? So I want to make it more general, right? Sometimes in the data, we can have more than one target variable also. You agree with me? Right? Give me the data, right? I might be interested in finding out identifying one variable based on the others, right? So this can change. I can't think of the example as of now, but let's keep it general, right? Sometimes it is evident what we want to predict, and the variable that we want to predict is the target variable. Okay? Perfect example, right? You can use that in the case of what is it? The Titanic data, where we want to predict whether an individual survived or not, then that is our target, right? And for a real estate data where the data about the houses is given, we want to predict whether what's the price for the house. So predicting price for the house, price of the house becomes the target variable, right? So that's what target variable is. Now issue here is that we can have different types of target variable, right? Types of target variable. We just saw we just discussed about two cases, right? That means what? Can they be different in nature? We've already seen two examples, right? That's my question here.
I don't quite understand the variables thing. Does that mean that the x-axis is the room numbers and the
You did not understand what, son?
the target variable?
Okay.
Does that mean that like the x-axis is the room number and the y-axis is just 0 and 1, or does it mean something else?
Guys, this is my file that I'll be using for review, right? Why did I open this thing up? Let's have our definition for target variable. It's not on in quiz, okay? Target variable. We can find better definitions, right? So the definition that I'm providing right now is based on your inputs and my understanding. So target variable is a feature in our data that we want to predict based on other independent variables. May not be the perfect definition, but let me see if this could be improved. Target variable is a feature in our data that we want to predict based on other independent variables, right? As an example, as an example for the Titanic data, if we want to predict whether, tell me, please help me with the typo. We want to predict whether an individual, WEA, right? So I will write that. WEA.
No, WH.
WH, whether, correct that, okay? But is it okay now? Whether an individual survive or not based on the other variables, then here survive or not is the target. Sounds good? I'll give it a better structure. Make sure that the meaning is clear. Yeah.
So it has to be in the data set, it cannot be something different.
Very good question. You must do research. Target variable, in the definition that I'm giving right now, it should be in the data. It should be a feature of the data. We will very soon discuss about the class of machine learning algorithms where the target variable is not in the data, but we still give it a target. Right? That is called a label that falls in the category of unsupervised learning, clustering and all. But there I don't think, I would not call that as a target variable. Right? So let's stick to this thing that for the time being, the target variable should be available in the data, right? There are a lot of things that we will be discussing very soon. That's one example. Similarly, for the real estate data, and if we want to build a model to predict the house price, that based on other factors or features like area number of bedrooms, etc. Here, what are the price of the house is the target. Okay. Did that help? Right? Do we still have questions? Questions are welcome. I love questions. Okay. Are these examples good? Do we see some difference in these two examples? The nature of target variable. Survive, not survive. How many possibilities? That's the binary case, right? Very good. Two possibilities, binary. Survive, not survive. Right? Similar examples we can think of, like if I have data related with health, say cancer, right? Whether that tumor is benign or malignant, if we have that kind of data, it's again binary, right? Email being spam or not spam, binary. Okay? Then we have the other case where the house price, right? What would you say about the target variable, which is kind of house price, right? Is it binary? It depends, right? It depends. See, that's the interesting thing about data science, right? If you want to argue, you can argue, right? When we are predicting the house price, can we make that a binary case?
Say like over 500,000, so that's.
There you go. Right? Expensive, not expensive. Who will determine expensive? Maybe I'll have a criteria, right? For a house which is over $1 million in Long Island, I'll call that expensive. Becomes a binary case. But let's not make it a binary. Let's deal it as it is, where the target variable is continuous. Okay? Here, the target variable is continuous. Okay? Here, the target is discrete, and I wish we had this topic in the quiz. Because a lot of interesting questions can be asked on this topic. But we have that only in the midterm. Binary, continuous, right? And we can have more categories also, right? Can you think of a target variable which is discrete, but we can have more than one class, more than one, more than two classes, right? More than two classes, like survival, non-survival. There are two possibilities. Can we think of a scenario where our model should be predicting more than one outcomes, more than one category, right? I'm using a category as a general term. Yeah.
It's like species of an animal.
Species of an animal. Okay, that's an interesting example. Yeah.
Weather, sunny, cloudy, rainy.
Very good. You would predict whether it is going to be sunny, cloudy, rainy. Fine. It's a valid example, right? Good. Good. So we know what is target variable, right? So guys, the reason we discussed this thing is that continuous. Okay, that looks okay to me. Fine. Target variable. We understood target variable, right? Now, fine. Let's discuss about the polynomial and non-linear functions. Okay. So target variable handle. Polynomial and non-linear functions. What do you mean by that? Are they really different? Why did we have two bullets for kind of similar terms, right? Polynomial, non-linear. Is polynomial also not a case of non-linear? That's a little confusing. Polynomial is also non-linear, but here, so when we have it non-linear, here it is about functions which are not polynomial, right? Like exponentials and other functions. That's the only reason why this thing has been split into bullets, right? What you need to understand is sometimes the model could be linear, like the simple linear regression example that we had. And for some data, the linear case may not be very appropriate. I'll show you very soon with an example. So in that case, we would need a polynomial function, right? And for some cases, our data would be even more complex, that we would need something like exponential function, right? So that's the reason it has been split. Now, here comes again another very simple, my favorite kind of definition, which says machine learning is just function approximation. But will you use this definition for the question that I have in the practice? At your risk, right? If this definition fits that, the context, right? My favorite is again the previous one, but it is a simple one, right? Maybe in the beginning of CSE 351, in second or third lecture, we can use this definition. Machine learning, just function approximation. Okay, let's keep moving. Question till now? Okay, so guys, let's look at this data, right? Very interesting. I do have the demo for this thing, but demo is still having some issue, which I kind of got to know because of the numerical instability. I'll see if I could fix that. So guys, here you are looking at the data, right? So we have a model here. The model has degree 3, right? So the model that we have is a polynomial of degree 3, okay? And the data is these blue points that you see, right? And then the true function is this red one. So this true function has generated these, points. So for the true function, some noise was added, and because of those noise, we got these data points. And our model is this blue line. All right, and as you can see, blue line is doing better. It's doing okay. I should not say better. It's doing all right, but it's kind of not explaining every points. Let's have a look at some scenarios, and here we go. Right, so I will run this demo, and we will understand some very interesting feature related with machine learning. So here, what do we have? Simplest possible model for this data, right? Can anyone answer this question, right? What is this model, right? Can you give a name to this model? This simple line that's trying to fit the data, but you can say it's not doing that great, right? Yeah. What is it called? Do we have a name? Can we be more specific? I think it is simple linear regression, right? I think I may be wrong. It's a simple linear regression. Why did you say that it's simple linear regression? There's only one variable, right? There's only one variable, which is the x-axis, and on the basis of x-axis, you have the y-axis, right? Simple one variable. We see, right? It's not doing that great. There are a lot of points which are not being explained. Almost all the points, I'll say, are not well explained. What we can do, this degree 1 is not helping us. It's linear regression or simple linear regression. So what we will do, let's increase the degree. And now, from here I should go to this slide, right? This is what we have with the degree 1. Let's go to the previous, slightly better with degree 3. And then with degree 57. Very complex polynomial, degree 57. And the good news, what? This plot that we have, or this linear regression model that we have, okay, is it still simple linear regression? What is it now? These few things you need to understand, okay? That is in the syllabus. What is it? Yeah. No, what kind of model? We'll discuss more later. Yeah. Here you go. Polynomial. Look at the degree. It is 57 now. Okay. Yeah, we have overfitting. We are going to discuss that. So here, what I should do? Let me run the code that I have. Okay. So again, I already mentioned the source, right? It's from that student's GitHub. Kulkarni, Vivek Kulkarni, if I correctly remember. So guys, here, as you can see, now it's for degree 1. I can use the control over here. Can increase the polynomial degree. With degree 3 it is better. With degree 10, 11, 12, see it's getting better. After some point, right, it kind of freezes. It doesn't improve any further. I searched it up, got to know that it has something to do with numerical instability. If I could fix the code, then with degree 57, it will go through all the points, right? So what was the purpose of doing this exercise? The purpose of doing this exercise is to get an idea about the fact that if you make your polynomial of a higher degree, then ultimately the polynomial or the model that you have will fit all the points, will pass through all the points, right? Now the question is, where should we stop, right? Is this thing good, degree 1, or is this thing good? Or maybe the slide that we have with degree 57, it is fitting all the points, right? So we need to get some intuitive idea about it. We will discuss these things in most systematic manner later when we'll start diving deeper into the machine learning. Okay? Good? Is my question clear? Which situation is better? Okay, how about this? How many questions have I given? How many questions are there in the sample quiz? the review sheet also. There are some topics in the review sheet also. Okay? And then it's up to you. Just prepare only those questions which are there in the quiz and go over only those points that I have in my review sheet and appear in the quiz. That's one approach possible. The other approach would be to go over every lecture slides that I have in the syllabus, have a better understanding of everything which has been taught, and not relying totally on the questions that I have practiced in the practice, right? Which approach is better? Memorizing all the questions that I have not provided you the solution, I have provided solutions. Right? Just trying to make the example very, very simple, okay? If my question is not clear, you can ask me for that. Even during the quiz, if any question is not clear, feel free to raise your hand. Okay? Right? And I'll very soon do the review. Yeah, just use 32 minutes and use 10-15 minutes more, and then we'll do the review. Should I repeat my question? Okay. So how about this? Let's think about a scenario where a student is only solving those questions which are there in the practice. And let's assume that I have 40 questions in the quiz, right? Not just 10, 40 questions in the quiz. And the student is only preparing those questions with the answers. If I ask those 40 questions, 100%. Right? And there's another student who's not memorizing the solutions to 40 questions, is rather learning the stuff, learning the material. Who will be doing better in the exam? Yes. Your answer is correct, but somebody can say it depends what do you ask in the exam. If I repeat the same questions, well, yeah, he knows the answer. But yes, your answer is correct. We should not memorize the data, okay? So here in this case, our model has become too complex, right? And here the intention has been different. The model wants to learn the training data really hard, okay? And this is called overfitting. We will discuss that later, okay? So the overfitting is not good. And we will be systematically learning these things with the help of bias and variance, those things, a little early. But yes, since we are kind of going over it, so it's no harm, okay, going over that. I should take you back to the lecture slide here. Now, if you were to pick this, and this one, right? I'm calling this as 1, 2, and 3. Which one would you prefer? 1, 2, and 3. The first one is with the degree 3. The second one is with degree 1. And the third one is with degree 57. Yep.
I would prefer 1.
We should prefer 1, right? Because we will discuss about these things. Right? The same, which I tried to explain. Here, we have the case of overfitting. In overfitting case, the model that we have tries really hard to learn the training data to the extent that it learns the noise as well. Alright, which we don't want. The model should not learn the noise, right? So these are some noise that we have added to the data. Right here. The true function is this red one, okay? These are some random noise which has been added to the data, okay? Alright, so now here again we have a very interesting picture that has been taken from scikit-learn. Now, there's a lot of information in this cheat sheet. So we are not going in every boxes that you have. We will focus a little bit on these regions. 1, 2, 3, and 4. We'll get some idea about what are we doing here. The attempt in this cheat sheet is to categorize the machine learning models into these different domains. Okay, so let's start. You can start from here, look at the data, You should have sufficient data. If the data is less than 50, then probably you should try to get more data. Now, from that data, you need to see what is it that we want to model. Okay? So, in modeling also, there are two possibilities, right? Whether we want to model the category versus some continuous value or the quantity, right? So, category could be, you people gave me the example of, what was that? Titanic data, right? From the data, you want to predict whether of the, an individual survived or not. So that's a category, right? And you people did give me some examples of category, right? Can we think of another example where we might be interested in finding out categories? Right? Data is given to us, and data will have, it is possible that data may have that information and data may not have the information that we want to predict. We're getting there very soon, okay? Is my question clear? Sorry? You want to predict wage and stone income, right? Can we predict that? We have data, maybe we can, based on the courses that they have taken, right? I'll take that. Another example. Okay, fine. Let's leave that for your quiz. Not this quiz, midterm exam that we do. But that thing is clear, right? Spam and non-spam we already discussed. And another very interesting problem, right, in NLP, which is sentiment analysis, right? If it could be for review also, right? Like review of an article was positive, negative, or neutral. We can think of these scenarios, right? And similarly for an X post, right, which we used to call as Twitter post, whether the sentiment is positive, negative, or neutral. Here are three categories, right? Even more interesting case will be for movies. Can you think about any target variable when the movie data is given to you, right? I'm giving you the hint. Movie data is given to you, right? Think of, and again, I'm not telling you what are the features. You could visualize what are the features for movie data, right? Now, data is given to you. Assume, just imagine what are the features available. Can we think about a feature which could be different kind of categories, right? Am I making sense? Movie data is given to you. Now for movie data, think about all the different, dimensions of features. Now can we think of some category there which makes sense to us, right? It should make sense as well. Yeah. Sorry? Sorry, I can't hear you. Rating, okay, yeah. So ratings means how many ratings do we have, right? Here I will need your help because I don't understand that domain really well. But yes, rating is there, right? So what are the different ratings? Which could help me with that. How many categories, right? Discrete, but how many? 0 to 5. Okay. 3.8, right? So the rating that you mentioned, it is about how good the movie is, right? Age rating, okay. So for age rating, we have categories, right? So what are those categories? Some parental guidance, I know, right? Rated, how much? So unfortunately, I don't know how many values are there. But yes, that is categorical. And I wanted, see, sometimes I want an answer, right? I'm just waiting for that answer. Yeah. Four or five, right? Very good. These are 5. Good. In the team, you get 100%. Any other categorical variable for movies? Yes.
The genre of the movie.
I wanted that answer. Right? Genre. Okay. So what are the different values that you can think of for genre?
Action. action, drama, horror.
Horror, right? Now, the reason why I kind of ask you people for this example is that for a lot of data, like your example that you gave me, right? Is it possible for a movie to have more than one labels for age rating? How about your rating? That's genre, right? Is it possible for a movie to have more than one genre? Right? So that opens another interesting, machine learning problem. Multi-class, multi-label classification, right? Well, anyway, we are not going there, but we do have some understanding of these categories, right? Good. So it depends on that data. What do you want to model? Do you want to model categories versus some continuous values? Okay. So well, you go here for category. Now again, it depends. Like, do we have labeled data? Okay. So for movies data, yes. What will happen in machine learning? That's what we do. We are given data. So let's assume that for movies we have genre information, right? We have rating information, whatever we want to predict. So that is considered easier. Well, again, I should not say easier though, but the life is easy in the sense that our data will have some information about what we want to model. Let me take an example actually. I didn't plan it this way. So in the previous cheat sheet that I showed you, we have to discuss this as well. Supervised versus unsupervised, right? So let's see what is this picture showing us. I will use my pen to mark this as picture 1, this as picture 2. On the data, right, don't worry about those, circles and all. How is this data different from the other data, right? Look at the circles only, okay? Here, all the circles are same color. You see that, right? Here, the circles are of 3 colors, right? So what is this color indicating? We know what? The class. We know the class. Very good. We know the class, right? So here, in this picture, these points that we have, which are in 2 colors, like I'll consider those green and blue, right? My knowledge of color is very poor. So these I'm considering as green, the other I'm considering as blue. So each these color points that we have are representing the points belonging to one class. Okay? So this is class 1, sorry, this is class 2, this area over here, and here is the class 1. So in this scenario, like the one that I have marked 2, our data has that information, right? It is like the Titanic data, if you are aware of. The data is given to me where there is a column which says whether an individual survived or not, right? So sometimes we are lucky when the data has that label information, okay, like the scenario number 2. So if you know that, if you're given that data, right, we call that as a training data. Sorry, TRAI. Right? Sometimes the training data, when we say training data should have labels. So from that training data, what do we learn? We learn a classifier. Okay, where is the classifier? Do you see the classifier there in this picture? What is classifier? Again, I need to explain, okay? So what happens here, in this case of supervised learning, where we have been given the data like class 1 and class 2, as you can see, class 1 are these points, blue points, whereas class 2 are these green points. Our model comes up with this kind of, boundary, a line, as you can see. This is called decision boundary. Okay, decision boundary. Who will provide this decision boundary to us? A classifier. Right? So it depends. Question. Right? So based on these color points, our model will learn this line. And if you think about it, then the line looks good, right? Is the line good? Is this line better? Or this line is better? Or this line is better? What we have is a good line because it is providing us the best separation. We'll go to those discussions maybe later. Right? Now, if you're wondering like what are these black points? These are unknown samples which are also called test data. Right? We want to see how good is our model doing in the test data. It's still a little early, but that's okay. Good? Now compare this scenario with the picture that we have on the left-hand side. Right? Do we have any training data there? Do we have any information about class labels there? Categories there? Right? Since we don't have any information about the categories or the classes like the scenario number 2, therefore we call that as unsupervised. Unsupervised where you don't know how many categories are there, right? Data is so simple that if you look at it, then yeah, you'll say 1, 2, 3, 4, 5. There are 5 categories. But how to find those categories, right? So, this is what he was asking, right? Here, we don't have any target variable. Do we have? No. So what we do in this unsupervised example that you're looking at, which we call as clustering, here you're doing clustering, here you're doing classification. What we do, using some very interesting clustering algorithms, we'll learn about those like k-means, DD-scan if the time permits. We look at the data, and from the data we try to identify this kind of grouping. Alright? One more slide on this and then we'll go back to the previous cheat sheet. Why is this interesting? Well, is the data same? Yes, the data is same, right? But in the picture that we have here that I'm marking as 1 versus 2, for 1 we already know the label, right? So the issue is that if I give you the same data, right, you can do either clustering or classification. Is that thing making sense? Right? If you ignore the label, discard that, okay? Just apply the clustering on the data, totally ignore that label information, you get something like number 2. Some grouping you'll find. And if you do a classification, if you apply a classification model, then classification model will come with a decision boundary. Question? Right? What will distinguish clustering versus classification? The labeling information, right? If you have the training data with an attribute, which is the target variable, then it is what? When you have the label, it is classification. And when you don't have a label, then that is clustering. Okay, questions, guys? I do have the reference of the document from where I borrowed these pictures, so if you need, you can go over those. Let's go back to this scenario, okay? So here, I have about 30 minutes left, less than 30 minutes, so I think we should do the review. Okay, go ahead.
I was gonna ask, how does the decision boundary look when there's more than 2 groups? Like if
Oh,
there was
that's
5.
interesting. Well, very good, very good, very good, very good. I'll have to come up with an example, right? It all, see, very good question, right? So he's asking this question that how would the decision boundary look like when we have more than 2 classes, right? I would say it depends on the kind of classifier that you use, right? Sometimes, like the classifier that we are using is a linear in the sense it is coming up with a line. Sometimes the classifier is non-linear, can come up with a non-linear boundary. But we will discuss that. I have the example. Yeah. When we'll discuss classification, then I'll show you how that decision boundary looks like. Okay? But depends, right? So let me draw this thing over here. It could look like this also. Okay? It could look like this also. Well, I don't want to jump ahead of that thing right now because I'm looking at the time and I have some 28 minutes for review. All right, let's do review now. The attendance sheet I already circulated. If the time permits, I'll come back and we'll have this discussion. So guys, let me first go over. I will remove this discussion on target variable because that is not there in your quiz. So yeah. CSA 3.1, yes. I will be sharing this document on the Brightspace, right? I'll try my best to upload that. Some general information. It is in person on Thursday, which is going to be 25th at 2:30 p.m. I will be teaching for initial some 30 minutes. And yeah, this is Javel's 110. You'll be getting 45 minutes for the quiz. And guys, this is about missing exam. Please don't miss the exam. All right. So again, I don't have the data. That is one of the reasons why I'm collecting this data, right? Your attendance and all. My experience is that the students who miss the exam, they don't do that well. Okay? I don't know. I don't have any data to support that claim, but that's my belief. So if you believe that you cannot you cannot attend the quiz, then please make sure that you follow these requirements. Okay? Makeup exam will be given, but only in the extreme cases. And I think I have this in the syllabus as well. I will share, so yeah, you can read. One thing that we have which is different from the previous semester is that cheat sheet is not allowed. Okay? And wherever we believe that you need formula, we will provide that. Right? So what will happen? Most probably, I will either have the formula in the question itself, or I might provide a different sheet with the formula. Right? So leave that on us. We will give you the cheat sheet. Okay? The reason being, there are a few things that you need to know. Definition you're supposed to know. I'm not expecting exactly the same definition that I have in my lecture slide, but yes, you need to show the understanding. Okay? Cheat sheet not allowed. Your SBO ID card is must. Don't forget that. Students do forget that, right? So you will not be allowed to take the quiz if you don't have the SBO ID card. Bring that. During the quiz, we don't want you to use your smartphone or smartwatch. Okay, so don't bring that, or if you're bringing, just put that in your bag. Okay, so you don't need the smartwatch or the phone because on the screen I'll have the timer, right? So it will be 45 minutes. I'll give you the quiz and then I'll start the timer and then I'll say, guys, now you can start. Okay, but that time would be enough. Alright, so now the syllabus which I have shared on the Brightspace as well. These are few topics, not much. Introduction to data science, mathematical preliminaries part 1, part 2, Python for data science part 1, Python for data science up to and including slide number 17, which is what which I discussed in the last class. So whatever we discussed today is not, except for the definition of machine learning, right? Which was up to slide number 17. The format, there will be 10 questions, 2 points each. Questions will be short concept based. You should expect questions asking short definitions, 2 lines, don't write too much. But I'll give you sufficient space. I don't know, maybe 2 pages printed one side, you can answer on both the sides, right? You won't need additional, paper, but if we'll bring some stat papers if you need. The questions are mostly going to be conceptual. What you can do is you can bring a calculator, scientific calculator, and just in case you needed to do some calculations, I will not allow you to use the phone, right? So for calculations, you should bring that calculator. Okay? Yeah, again the same thing. Cell phones and smartwatch is not allowed. It's closed book, closed notes, a paper-based printed quiz. Okay. Any question? Fine. Now there are some things like what you are expected, but again, it is not possible to discuss everything in this simple document, right? So that's the reason I'll request you guys, if you have any questions, feel free. Okay? So as an example, you are not expected to memorize the formula for Pearson correlation coefficient or Spearman rank correlation, as these will be provided if I'm asking these questions. Now I had some very interesting interactions with the students in my office hour, and yeah, I'm happy with my TAs also. Right? Some TAs went beyond what I taught in the class, right? Like in your homework, when we are doing Spearman rank correlation, right? The data has some duplicates. Right? With duplicates, it brings another interesting point, that how do we rank when we have duplicates data, right? TAs, they came to me, I told them how to do it, some of them they figured it out, and interestingly, as I was interacting with the student, one of the TA also figured out the formula to be used when you have duplicate ranks, right? So yeah, which I don't have in my lecture slides. Maybe in future I will add that. So the deal right now is that the question that I'll be giving you in the quiz or the exam, where you'll have to create, where you'll have to find out Spearman's rank correlation, we won't have any duplicate rank, right? So that way you could use what? The existing formula. Good? And yes, for that I will provide you the formula. If I'm asking you to compute the Spearman rank, then I will provide you the formula. But only formula will be given to you. The rest you need to understand. If DI is there, I will not tell you what is DI there, right? You need to know. Okay? So you need to understand those terms there. You are okay. So how about this? Guys, feel free to ask questions, right? If you have any. You are expected to understand Bayes' theorem, conditional probability concept, basic probability concept, and formula for these topics will not be provided. Okay, Bayes' theorem is such a fundamental concept that I expect my students to know that. Okay, and believe me, if you watch the recording, I have given you the trick. Right? If you don't remember, first of all, you don't need to remember anything. Okay, you need to know the conditional probability thing, joint probability, and you can derive it. Right? The issue is you can derive in just one line. And yeah, for the question based on Bayes' theorem, the tricky part is understanding the question. Right? Formula is very simple. Sometimes the question is a little tricky to understand. Right? So it's more of reading comprehension kind of. Understanding the English. If you understand the English, then yeah, you can easily, extract what is PA, what is PB, what is PA given B, right? So those things. This is what you need to get from the question. You need to understand these few things like logarithms, the applications. I asked this question in your homework also. Okay. How many of you have submitted your homework? How many of you are not comfortable with the deadline? Feel free. Chances are I might extend it because there are some students who are who are requesting. So for me, it will be convenient to extend for everybody, right? So most probably somebody should remind me about it. Okay, remind me tomorrow morning. I'll extend it in the morning itself. Most probably till 28th. That's the request which is coming to me. Okay, fine. But while you're preparing for the quiz or exam in future, do look at the homework also. Right? The question could be asked from the homework also because you should know what you're doing in the homework. Okay, so this question has been asked in the homework. Now, you're not expected to understand those tricky Python code, right? Like the one that I have for web scraping. So you're not expected to understand the Python code for tasks such as web scraping and or modeling. I have this example over here. But you are expected to be familiar with the names and functions of key Python libraries for data science is expected, right? So Python for data science part 1, if I could correctly remember, there we have, an interesting picture with different stages in the data science project and the corresponding libraries. So you are expected to know those things, and you should be comfortable with the random variable, its definition, and the example that we have. And yeah, the last point that I have here is giving some idea, like we can do a lot in Pandas, right? But at least you should be familiar with what we have in the lecture slides, right? Importing Panda, read.csv, add, tail, NumPy, what is NumPy, those basic method examples that I have in my lecture slides. Similarly, SymPy, what is SymPy, right? We also discussed about the difference between the linear algebra package that we have in NumPy versus SymPy, if I calculate the number, right? So these are a few things that I could remember. There's not much, only few topics. But yes, in my notes, these are the things I could think of and type. And I was asking, right, you people to come up with your questions and let me see if you have any questions, right? Like, good with this information? I'll have my office hours tomorrow. You're welcome to join me in my office hours. What next? Next, I will discuss the practice test that I had. Solution, and solution is again something that I'll be providing. Okay. So here, true and false question, right? Do we know the answer? CDF has more information than PDF, or PDF has more information than CDF? Sorry? True or false? False, right? They are basically the same thing. And we discussed this in the class also. List any 2 interesting facts that you can find using Google. And this is a question directly taken from the lecture. Okay. So what I did, the solution again taken from the lecture. Simple. Using an example of an experiment, define the concept of sample space and probability. And I'm using the same example, which is the sample space of an experiment in probability refers to the set of all the possible. As an example, if in our experiment we have 2 6-phase dies, one color red color, then yeah, So this example and definition is again from our lecture slides. Okay. Now we discussed about overfitting, right? We discussed about data collection also. Okay. And you should think about why I'm disallowing the cheat sheet also. Because the students in my class, they were overfitting to the exams that we had. Right? I don't know how much you're getting cryptic. So I will not be asking any question from this side. I should not, right? Otherwise, how would I evaluate the models who are sitting in front of me? You are all models, right? Agree with me? Much, much smarter than AI. I still believe that AI can't beat human beings. Okay? So the purpose here is to get some idea about the nature of questions. Okay? Will not be exactly the same, but could be a variation of that. Right? Making sense? Okay? But yes, you can still, what you should do, I mean, maybe when you feel that you are totally prepared for the quiz, then yeah, you can look at this sample. List any two centrality measures from descriptive statistics. Again, we discussed about these mean, median, geometric mean. Now here, this is an interesting problem, okay? Because I won't repeat the same question, but the chances are I might be asking something similar, but from a different data set, okay? To see whether you understood that discussion that we had in the beginning of the semester or not. Probably it was in the introduction to data science. Okay? How can we ask an interesting question on the data? Right? So here the question is that you are given the time series data for 23 years of hourly electric energy demand of Brazil. List any two interesting questions that you will ask on this data. This data has two columns. The first column is the combination of date and time, and the second is hourly demand. Now, your questions could be different, okay? But your questions should be interesting, right? So, don't worry about, we have some directions, right? Like, well, you can think about checking if there is any seasonality, like higher electric energy demand in specific seasons, like summer or winter. If there is any pattern of power demand during the hour of the day. If there is a seasonal pattern in terms of power demand over weekdays, right? And yeah, so some general questions that you could think of. Okay. Now, this question, please ignore the question number 6. We didn't discuss this part. List any two Python libraries commonly used for data preprocessing. So, this kind of a question you can answer if you remember that slide, right, where we have different stages. Okay, just a second. This question is coming from, no. This, okay? Very interesting slide, important slide. It gives us some idea about different packages. Right? So have some idea about these, where exactly these libraries fit. All right. So any two, right? Question says give any two, but I have listed 4 in the exam. You're required to provide only 2. Any 2. For here also listed 3. You need to provide any 2. Now this is interesting, right? Which we kind of discussed also. Like what is machine learning? Explain how it is different from the traditional programming. So let's see what we have. Again, a different definition of machine learning, right? It says machine learning is a field of computer science where programs learn patterns from the data and improve their performance on the task without being explicitly programmed. This is interesting. Without being explicitly perform. Okay? Without being explicitly performed, the program learns from the data. Machine learning is a field of computer science where the program learns patterns from data and improves their performance on the task without being explicitly programmed for every scenario. It differs from traditional programming because in traditional programming, the rules and the logics are explicitly coded by a programmer, whereas in machine learning, the system learns the rules and makes the prediction on the data. Okay? Right? Why? Probably we discussed about it, right? The machine learning, we need machine learning for those kind of scenarios where unfortunately we cannot describe the phenomena using a well-defined function. Am I making sense? Right? For your letter grading, the system is so well defined, right? The rule is so well defined that you don't need to learn from data, right? But if the task is like this, see, I told you, right? When I said that please don't miss the actual test because I did not do any analysis, but I believe, right, those students who are not appearing in the actual exams, they don't do well. If I have to build a model which is kind of predicting the grade of a student based on the attendance, right? Based on missing the exam or not, you understand? And this is slightly complex because we don't have a perfect function. Okay? I hope I'm making sense. What is the difference between the probability and statistics? It is again taken from the lecture slide directly. Probability deals with predicting the likelihood of future events, while statistics. Okay? What was the last question? Okay, when will you prefer Spearman rank correlation over Pearson? It's again taken directly from the lecture slides. Okay? Now, question for me. Or any request? So, what should I do with in the remaining 7 minutes? Should we discuss about this only or should I move on to the next topic? Yeah, go ahead.
I guess question 7.
Question 7.
Do the options we choose depend more on the graph provided, or libraries we could potentially use for that service?
Your question is that the answer provided should that be based on what was taught in the lecture versus your own knowledge? What is it?
Yes, because I noticed that NumPy is used as an answer for question 7, but NumPy is not graphic processing.
You know, very good question, right? NumPy, see, I mentioned this thing, right? You can answer the question based on your knowledge as well, right? Sometimes, my slides may have some, mistakes, right? So, in our slide that we have, right? One of the models that has been given for pre-processing is Matplotlib, right? But I checked Matplotlib is for visualization, it is not for pre-processing. Okay? So for that reason, I removed that. And I had this understanding that probably NumPy can be used for pre-processing, right? And I figured it out and I have that installation. Right? So see, if your answer is based on what I taught in the lecture, right, then I can't take the points off. Am I making sense? Because I taught that in the lecture. But if you believe that you have a better answer, please use that. Okay, did I answer your question? So just to summarize, we have in our lecture slide, maybe I'll remove that next time when I'm teaching, that yeah, Matplotlib should not be in that category. But yes, NumPy should be in that category because you can use NumPy for pre-processing. That's the reason I have NumPy here. Okay? And I also mentioned that, we use other resources also when you're preparing for the exam, right? Go beyond what I'm teaching, as some of the TAs are doing it, right? I mentioned about the formula for Spearman rank correlation when we have multiple values. Should be a different one, not the one that I have in my lecture style. Okay? Good. What are the interesting topics that I did not discuss? Maybe we can have possible questions. I still have 4 minutes, right? I want to use that for review. Yeah, you have a question? Well, wait, is it from it is from lecture slide? And what is the question? A disordered pairs, right? So I believe, disordered pair is something we discussed when we were doing Spearman rank correlation, right? So let me go there. I need an example. Disorder means it is, for the, it's not this one, this is the second one. Yeah. The number of disordered pairs, disordered means where, how about this, one student, okay? It's say data science and some AMS course. Assume that the student is taking both, right? So if the student is ranked number 5 in data science but ranked 7 in what is it, AMS course, then this is kind of disordered, right? Because the student is ranked higher in data science but comparatively lower in AMS course. So this is disordered kind of thing, right? So, and that will anyway figure out in the example if you see. The difference, when you find out the difference, in that D factor, we do compute the difference in the rank, right? So that's what it is. As an example, for this record, wait a second, because we still have a couple of minutes. It's a very good question that she asked. Here we go. This one, right? Oh my God. Yeah, just review. Come on, yeah. So here, this is an example of disordered pair. Why? Well, the rank in English is 5, whereas the rank in math is 9. Whereas this is called, right? This, your rank in English is 1, your rank in math is 1. Right? So in this expression that we have, which is over here, this factor, di squared, it is capturing the number of disordered pairs, right? If that was, let's assume that the ranking was same in both the, how about it? If we were to compute the Spearman rank correlation involving English and English only, English and English, right? Both the variables are same. Are we going to have disordered pairs? Making sense? If I ask you to compute the Spearman rank correlation with English and English only, right? The same duplicate data. Are we going to have disordered pairs? Okay. Right? Right? So that's what we have. Here, since those courses are different, the ranks are different, right? As in some instances that I have highlighted, like 5 and 9. Here we have disordered pairs. Whereas in other we will see. Well, guys, I'll see you next time. Good luck.